When you look at images of Earth, probably in a space magazine or even a textbook, you'll probably notice one thing. None of the pictures seem to have a satellite on them. Have you ever wondered to question why? Why do you think there are no satellites visible in any of the numerous images of the Earth if they are taken from a considerable distance? I guess this has tickled a thought in your mind, but if you think about it, many artificial satellites are orbiting the Earth. And considering 500,000 particles of orbital debris, and not to forget the remaining 21,000 bigger objects rotating around the Earth, why can't these be visible in the multiple images we have? In today's video, we're going to break down why exactly there are no satellites in the picture of Earth. Let's talk about satellites. Satellites are nothing but man-made objects. Several tens of thousands of them float in the exosphere and even further. But let's consider one, the ISS for instance. It is roughly 109 meters by 73 meters in size. It is somewhat bigger than a football field. And you must have understood the size to some extent. You wouldn't have guessed it, but this is one of the biggest and most expensive artificial objects ever to orbit the Earth. Then there are others such as the Hubble Space Telescope, AstroSat, NOAA 18, and numerous other Earth observation satellites constantly revolving around the planet. And now, space debris. Numerous broken satellites out there cannot be repaired. Keep in mind that this list that we mentioned only includes the ones currently functioning. So essentially, they'll need to hang around in the upper atmosphere until they gradually lose altitude and burn up. Future space missions should be very concerned about the enormous amount of space garbage these many kinds of satellites add up to. And then finally, we've got natural objects. Tens of thousands of celestial objects, man-made satellites, and space debris are orbiting the Earth. These items range in size from a few centimeters to a few feet. So now, back to the question. Why can't we see satellites or other heavenly objects in photos of the Earth? The reason is quite simple to understand. Earth is enormously large. People frequently underestimate the size of our planet. However, it's difficult to pinpoint why. Our planet is enormous in the most accurate meaning of the word. By contrast, the planet's orbiting objects are puny, for want of a better phrase, to describe their minuteness. Suppose you consider the ISS, which we've mentioned as the largest man-made object presently rotating around the planet. In that case, the surface area is roughly 2,500 square meters or 0.0025 square kilometers. This is roughly an estimate of an apartment with 6 bedrooms in size. Meanwhile, the Earth's surface measures 510.1 million kilometers squared. So let's do the math. We know the surface area of the ISS and the Earth, so tell me your wildest guess. How many ISS do you think are required to cover the Earth's surface completely? Well, if you did the math, you will see that 204 billion ISS are needed to completely cover the Earth. Although satellites can be seen in the Earth's images, their size prevents them from being clearly visible. Most photographs of our planet only have a few thousand pixels in diameter. Therefore, unless an item is larger than that, which none in this planet vicinity is, it would only be a fraction of a pixel and would be undetectable in the image. However, there are times when a satellite can be seen in an image of Earth, but it would be too small, like magnifying glasses small, and nearly impossible to identify from the background stars. Does this mean that the camera capturing these shots is sensitive? Well, to answer that, let me ask you a question. How much light is required for your camera to function? The aperture that admits light can be opened and closed in fancy cameras to change the sensitivity. The pupils of human eyes automatically dilate and constrict regularly, performing the same action. If you're sighted and move from a well-lit outdoor area to a dark one, you won't immediately see any stars in the sky. You gradually become able to see fainter and fainter stars as your pupils enlarge and your eyes get more sensitive. In reality, most space cameras cannot change their aperture in this manner. Instead, they plan their instruments with an aperture that is the right size for the range of targets they anticipate encountering and predict the light levels that a camera will experience during its mission. This could be a challenge if your spacecraft encounters a wide variety of target brightnesses. However, you should configure your camera to work on the intended science targets. Don't worry if it isn't ideal for any amusing extras you may photograph along the way. When OSIRIS-REx looked at Earth, the map cam on board, whose purpose was to investigate the colors of a very dark-toned asteroid, was overcome by the intense light reflecting off of bright clouds, resulting in the artifacts that you see. What is the dynamic range of your camera? Can your camera capture objects in both low and high light conditions in the same picture? Or does its ability to collect light quickly get overwhelmed by brighter objects before it can see any light from the darker objects? Here, our eyes typically perform far better than cameras. How long does your camera have to collect light? Well, longer exposures gather more light than shorter ones, making it easier to see fainter objects. Human vision doesn't have an equivalent for exposure settings. We notice more when we stare at something for extended periods, but that's not quite the same. Long exposures, frequently lasting several minutes, are required for photos of the starry night sky because it takes a long time for the camera to gather enough photons to produce a pleasing image. Stars are not captured by short exposures. A vast range of exposure settings is possible with space cameras. For instance, the LORRI camera on New Horizons can capture photos with exposures as little as 1 millisecond and as long as 30 seconds. They selected the shortest exposure option when they were passing Jupiter, which is much brighter than Pluto and far closer to the Sun. For the faintest of targets, distant worlds in the Kuiper Belt, they employ the longest exposures. LORRI may be used with various exposure settings and has a fixed aperture with a tremendous dynamic range. The lava-filled moon Io is one of Jupiter's most fascinating objects. This LORRI image was captured when New Horizons drew near the Jupiter system. A 4 millisecond exposure was utilized. There are no stars to see, and Io is well exposed. A little while afterward, LORRI captured another image of Io with a 75 millisecond exposure. At least 3 volcanic plumes are visible rising from Io's surface. The plumes can be seen in rich detail in this exposure setting. Most people are unsure if any stars are visible, even with an exposure almost 20 times longer than the one used for the Io image above. 2 days later, Io was seen in the second series of Io photos, having migrated around Jupiter and into its shadow. Io's surface is not receiving any sunlight. Thanks to its heated volcanic plumes, it lights up brightly in the dark. Stars remained visible in their lengthy exposures as New Horizons got closer to Pluto. These approach animations still show the stars, and the one below, amateur photographer Matthew Earl used the stars to line up the pictures and illustrate Pluto and Charon's peculiar dumbbell spin. So, when thinking of why satellites aren't visible, you might as well focus on asking, what in the image is so bright that I can't see the satellites? The answer would also be that the satellites are too faint to be visible. To give a real-world example, everyone watching this video has probably made the error of taking a picture of a loved one in front of a brilliantly lighted window. Your subject's face is a shadow with almost no features that you can discern in your photograph. Of course, their face is still there, just simply put, it's not sufficiently well lit to appear in the picture. Space images suffer from the same problem that might ruin your casual photos. The sensitivity of the camera, the amount of the time the camera has to gather light, and the dynamic range of your camera are the 3 factors that will determine the level of detail that you can see in any photo, whether it is of a star, a planet, or a human. Satellites and other objects in orbit of the Earth are invisible in photographs of the planet because they are too small to be seen in relation to Earth. These items cannot be seen in the same image because the Earth is too large. Similarly, whereas on Earth we are accustomed to seeing dazzling stars dot the night sky in space, the sky is constantly as pitch black as darkness. But it turns out that the analogy is flawed. Because of the atmosphere's role in light diffusion, our midday sky is bright. There is no atmosphere in outer space or on the moon, so the sky will appear black at noon, but the brightness is still just as strong. On a cloudless day, an astronaut peering out the space station's window will see just as much direct sunlight, if not more, as I will. However, astronauts have captured numerous images of the satellites from space, some of which may also be accessible on NASA's website. Sadly, none of them feature astronauts performing spacewalks in the foreground. But what are your views on this? Is there some other reason that you can cite for the satellites not being visible? Please share your thoughts in the comment section below. And give us a thumbs up if you enjoyed the video, share it with your friends, and subscribe to our channel for more content.